Viewers, today our topic is the healing error of magnetic compass. What are the reasons for healing error with the full details of explanation? Please check. Viewers, today is our also continuation of class for magnetic compass. Today is the healing error. Yesterday we had class here. We shown that how to calculate the coefficient yesterday class. If you check my last videos, you can see. So today is the healing error. Viewers, this healing error is caused only when vessel is healed over. Only that time this healing error occurred. Other time no healing error. Okay. So normally vessel will heal. This is the normal things for a ship. So this healing error cause for that. So there are three causes for healing error. One is this permanent magnetism, R force, induced magnetism BSI above or below, and another is induced magnetism HSI when healed, that time induced by Z. So I think guys you remember that in permanent magnetism, here I left this R force. I told that this one I will discuss later on because this is for the vertical component. Okay, this force is for the vertical component, and here BSI above or below, this one also I left. So these two is the reason for healing error. Okay, one is for R force from PM, another is for BSI above or below from IM, and one more additional, that is the HSI. When HSI means this one HSI when heals induced by Z. So these three is the causes for healing error, and for this healing error that J coefficient come. Okay, so ultimately this is the healing error for the J coefficient. Okay, so viewers, you see when a vessel upright condition, there is no heel, no list, so this Z force acting vertically downwards. So here there will be no effect when vessel is upright condition. Okay, but when vessel is heeled over condition, heeled to any side, when this Z force acting vertically downwards, that time there will be create another component. This is the vertical component is okay towards downwards, and this is the horizontal component, and this will create the healing error. So this one will explain one by one for PMR and other also, guys. Viewers, if you check first for the R, that is from the permanent magnetism, so this can be R plus, can be R minus. So this one I will show you from the hemisphere, like one vessel is in the northern hemisphere, another is in the southern hemisphere. Guys, you know that line of force is passing this way. Okay, and which way line of force go in, same like a vessel on the northern hemisphere on deck will be the blue polarity because of the line of force is coming in. Okay, and this way come out, so red polarity on kill. So here come in, on kill it will be the blue polarity, and on deck will be the red polarity, correct? So line of force is passing this way. So for the northern hemisphere, this is vessel, okay, this one, so this green polarity on deck, correct? So line of force is coming like this way, so there will be no effect on here. Okay, no effect. And when vessel heel over any side, like on the starboard side heel over, so this is the vertical components created by the line of force. Okay, so these vertical components, no problem, this is same jet force, so this is not create any deviation, but there will be another component will create horizontally to the high side of the hill, high side of the rule. Okay, this is the high side of the rule, so these horizontal components will create the deviation, guys. Okay, same here for the ruling for the port side, so this line of force is acting downwards. Okay, no problem, but one horizontal components will create on the high side of the ruling, high side of the ruling. This vessel is ruling, this side is the low side and this side is the high side, you know that. So this horizontal component on the high side, this will create the deviation. Okay, guys. So, and you know that this is the another vessel is on the southern hemisphere, and this line of force pass in from kill out from deck. Okay, like pass in from kill out from deck. Okay, this clear. So since this is in the upright condition, so there will be no effect, there will be no deviation, guys. Okay, so once vessel heel over or roll over, that time it will create the deviation. So here this one, so one force will act vertically upwards just, and another will create on the horizontally to the low side. This is the line of force. Okay, so line of force one will go upwards, another will create the horizontal components. Because of, guys, this vessel is heeled over, here vessel is not heeled over, so there will be no components, no horizontal components, but for this it will create the horizontal components that will act towards the low side always, remember. Okay, so southern hemisphere always this will create towards the low side, so deviation will create towards the low side, but in northern hemisphere deviation will create on the high side, remember. Okay, because of on the northern hemisphere line of force coming from top. Okay, but in southern hemisphere line of force come in from bottom. Okay, remember, guys, this one you understand, guys, how this coming. So now for the induced magnetism, and that is the VSI, the VSI above or below. Okay, so you know that, guys, there is no VSI above, because above means above the compass there will be nothing, so it's always on the below. So on the below means below, here one VSI I placed. Okay, okay, so line of force is passing this way. Okay, so if I put one BSI here, so which way the line of force go in, that is the blue side, correct. And this here also we understand the line of force pass in, that will be the blue side. So this BSI, this side is the blue side, so bottom is the red, correct, correct. So for this also same, this way line of force is pass in, so will be the blue side at bottom, correct. And on this BSI the red is on top, correct or not, guys? I think you understand this much, because this is for induced magnetism BSI above or below, so we are working only for the below one. So I'm just, this is the basic, guys, for the line of force I'm passing in is blue, out is red. Okay, so viewers, in northern hemisphere this force is acting downwards, when vertically there will be no deviation, because it's acting just vertically downwards. It's no problem, because of your BSI below is in a line with the force, so no problem. Okay, but when heel over, that time the problem will come and deviation will create. So viewers, when heel over, that time one components will act vertically downwards, and another, since it is northern hemisphere, and it will act towards the high side of the roll, these horizontal components will create the deviation. Okay, so we can see from here also, from R also, this in R also, in the northern hemisphere these vertical components is downwards, no problem, but horizontal components towards the high side, towards the high side of the rule. Okay, so here also for the induced magnetism BSI below, for this also in northern hemisphere these horizontal components acting towards the high side of the rule, so deviation towards the high side. Okay, and for the southern hemisphere, you see this line of force is passing from keel to deck, correct. So it's like this, guys. In the southern hemisphere, you see this one, this red is on top, correct. This red side of the BSI is on top side, and this blue is, means blue polarity is downwards, so I put like this, and this force is acting from keel to deck, like this. Okay, keel to deck. So from keel to deck, if a vessel is upright condition, there will be no heeling error. Okay, but when vessel heeled over, that time the problem coming. So when vessel heeled over towards the starboard side, this will create one components upward, because of vertical force acting from keel to deck, you see here. So from keel to deck, and one more component will act like this way, that is the horizontal components. So vertical components, this one I have no problem with this, but this horizontal components I have problem, because of this will create the deviation. So you see in southern hemisphere these horizontal components. Guys, now you see this in the southern hemisphere, this horizontal components is on the low side of the rule, correct? Low side of the ruling. Okay, same for the R also. In the southern hemisphere, these horizontal components in on the low side of the ruling. This is the high side of the ruling, and this is the low side of the ruling. Understand, guys? So in both cases, so viewers, for number 3, this HSI when Hill induced by Z. Viewers, you see here, if I put the HSI, it means horizontal soft iron. So if I put HSI like this way, if it is vessel is upright condition, this line of force will make 90° with the HSI, correct? 90° with the HSI, so there will be no polarity, so there is no problem, there will be no deviation. But when vessel heels from here, when vessel heels over this side or this side, that time this HSI also heel with the ship, correct? So suppose I heel like this, suppose ship heel towards the on the starboard side, okay, towards the starboard side. So if this is HSI, so here so here, since this line of force is come in this way, so since this is the upside of the HSI, so this side will create the partial polarity will create by the blue polarity, okay, and this low side will create the partial red polarity, correct? So same here. If I vessel rule on this side, so this is the HSI, okay. So since line of force is coming, so blue polarity will be on the low side, correct, and this side will be the red polarity. This is a partial polarity, guys, okay, correct, guys? So viewers, this is the normal vessel upright condition. This is the HSI. So line of force is passing like this 90°. There is no polarity create, so no problem, there is no deviation, okay. And viewers, when vessel heels over, that time you see here the same. If I draw here, will create the this side create the partial blue polarity, this side create the partial red polarity, correct? So when line of force passing, it will make like this. One is this way and another is towards the horizontal components, correct? So these horizontal components will create the deviation, and you see this also, since this is in the northern hemisphere, this is also coming to the high side of the ruling. You can understand this one, same in the northern hemisphere, high side of the ruling, okay. So viewers, in the southern hemisphere, you see this is the your vessel is in upright condition, your line of force is acting downwards from down to up, you see, from down to up, okay. So here is no effect because of vessel is in upright condition. But when vessel heels over, like on the starboard side, this opposite create here, okay. This I already discussed here how it create the polarity. So viewers, when the line of force will pass in, that time this will make the horizontal components on this side and vertical components on this side. This is the resultant. So these horizontal components will create the deviation, okay, guys. So viewers, in all three cases, this is the three cause. We can see that in northern hemisphere, always this deviation towards the uh, high side. You see, northern hemisphere deviation will be towards the high side, and southern hemisphere deviation will be towards the low side. In all three cases is same. This is proved. Understand, guys? I already proved by the figure. So I think you understand that what is the causes of healing error and how these three causes occurred, and I already discussed, guys. I think you understand a little bit. And this healing error is caused for the J. There is a coefficient J. So viewers, I already discussed these three causes. Guys, this coefficient J is for the healing error, okay. So there is a formula for healing error calculation. Healing error is equal to J into I into cos compass course. Because of this healing error is varies with cos compass course, so J coefficient value is like this, healing error by I into cos compass course. Because guys, if you check this one, this is very like this, okay. This varies with the cos compass course like this, okay. So I think, guys, today I'll stop here. Next videos I will discuss some more about this one, and also healing error character, how you will correct the healing error bucket, and how this looks like and how everything you have to put in the healing error bucket. Okay, so thank you too much. Bye bye.